So in this video, I'm going to talk about solving quadratic equations, and I'm going to show you basically every technique that you'll ever need in order to solve a quadratic equation. So if you use one of these techniques, you'll get an answer, and boom, you'll be done. So let's start off with the quadratic equation. Let's say x squared plus 5x equals 14. So again, remember a quadratic equation. We have a variable raised to the second power. You may or may not have a term involving just x, and then you'll have a constant floating around. So that's going to constitute a quadratic equation. If you have other terms, like say x to the third in there, that's no longer going to be a quadratic equation. So the first thing you always do is you make one side equal to 0. So we want to make one side equal to 0. And typically, I like to keep my x squared term positive. So the first thing I'm going to do, well, I see this 14 on the right side. I'm simply going to subtract 14 from both sides. So on the left side, we would have x squared plus 5x minus 14. Notice we don't have any like terms on the left side, so we just keep everything. On the right, 14 minus 14 is simply going to give us 0. Okay, so we've got this first step done. We've got one side equal to 0. And now what we try to do, there's lots of different things you can do. You can try to factor. So I'm going to talk about factoring, and I'm going to factor by trial and error. So we can factor by trial and error. We can factor by grouping. So we'll look at one using grouping. And then another thing that we'll do is to use the quadratic formula. Okay, so the idea in this case is, if it factors again nicely, I'm doing air quotes here, we want two numbers that multiply to negative 14, but add, so I'm looking at the constant here. So you want two numbers that multiply to whatever your constant is. In this case, it's negative 14, but add up to, you look at the coefficient on the term involving x. And in this case, we want them to add up to positive 5. And again, this only works if the coefficient on x squared is a positive 1, which we have here. So that's one thing to remember about this. So our coefficient in front of x squared is positive 1. So I'm looking simply for two numbers that multiply to negative 14 but add up to positive 5. Okay, so negative 14. Let's think about some numbers. I could use some combination of positive 1 and positive or negative 1 and positive or negative 14. If we're going to multiply them, right, one has to be positive, one has to be negative. Then I think, well, what other numbers multiply to 14? Well, 2 and 7 would work. And again, one of those has to be positive, one of those has to be negative. But it looks like in this case, okay, I'm already thinking about combinations of 2 and 7. It looks like if we use negative 2 and positive 5, or excuse me, negative 2 and positive 7, I was looking at what I wanted to get out. Negative 2 and positive 7, those do multiply to negative 14. But notice if we add those, we do get positive 5. Negative 2 plus 7 is going to be positive 5. So what that tells me is I can factor this. Using those values, I'll have an x in each set of parentheses, and then you just drop those numbers in. So I've got x minus 2 and x plus 7. I've still got the equal 0 on the right side. And notice if we multiply these out, x times x is going to give us x squared. X times positive 7 is going to give us positive 7x. Negative 2 times x is negative 2x. And then negative 2 times positive 7 is negative 14. And if we simplify the middle terms, now we do have like terms. Again, we will get that positive 5x back out. So it looks like our factorization is in fact correct. So we have x minus 2 multiplied by x plus 7 equals 0. What we do at this point, once we have it factored, is we just take each of these factors and we set it equal to 0. So I've got x minus 2 equals 0, x plus 7 equals 0, and then we just solve each of these respective equations. So for the first equation here, I could simply add 2 to both sides, and that would give me x equals 2 as one of my solutions. And then for the second equation, I would simply subtract 7 from both sides and get x equals -7. And now we found the two solutions to that quadratic equation. So again, the coefficient on the x squared needs to be a 1. You want one side equal to 0. But then you're looking for two numbers that multiply to the constant and add up to the term in the middle. Okay, so let's look at another example here. So a couple more here. So let's look at, so this will be my second example. Let's look at 6x squared. Let's see, plus 5x minus 4 equals 0. So notice in this case, I've went ahead and made one side equal to 0. I mean, we could change this up even and say, you know, maybe it was a 6x minus 4 equals -5x. Suppose it looked like that at the beginning. Well, I would think, again, this is quadratic. I've got this x squared term. I've got a constant floating around. I'm allowed to have an x to the first power. That's okay. The first thing I would think is, again, I need to make it equal to 0. So in this case, we could add 5x to both sides. So I would have 6x squared plus 5x minus 4 on the left. -5x plus 5x on the right, again, would give me 0. So same idea. We're going to make one side equal to 0. Now, we kind of did this first example sort of just by trial and error in a way. And you could do the same thing on this one. The problem now is when I do the stuff with parentheses, okay, I've got equals 0, I'm going to need two numbers that multiply to 6 on... I'm going to need two numbers that multiply to 6 because this is where I'm going to get my x squared term. So already I have some options. I could use, you know, 1x and 6x, or I could use a 2x and a 3x. Both of those, when I multiply out, are going to give me my 6x squared, which I want. Now, we also need to get a -4. So already I know that one of my signs has got to be positive and one is going to have to be negative. So I could maybe use a +2 and a -2 here, or, you know, maybe I could use a +1 and a -4 here, or maybe I make the 4 positive and the 1 negative. So already you can see there's lots of different sort of factoring possibilities. And there's a way to rule a few of those out. I'm not going to touch on them just now, but I'm really just trying to show how this can be, you know, really sort of tedious, you know, which one of these works, because we have all these sort of different possibilities for our first two terms in the parentheses, and then we've also got these other possibilities for our constants, right? I could use 2's and 2's. So if your coefficient has lots of factors, and if your constant also has lots of factors, you're going to have lots of different possibilities to check. So sort of brute forcing it sometimes can be tedious. So this is where we can talk about factoring by grouping. So this is another useful technique. So okay, let's copy this back down. 6x squared plus 5x minus 4 equals 0. And it's going to be very similar to what we did in the first example. So in this case, what we do is we take the coefficients on the x squared term and our constant, and we multiply those together. So I'm going to take 6, and I'm going to multiply that by -4. That's going to give me -24. So this is where it's going to sort of be similar to what we did a second ago. Now I want two numbers that multiply to -24, but add up to, again, the coefficient in the middle, but add up to +5. So this is sort of this extra step here. So we're multiplying the coefficient on x squared, we're multiplying our constant. We want to find two numbers that multiply to that, but again, add up to the coefficient on x. So I could already think, again, I know I'm going to need some combination of a positive and a negative, so that when I multiply them, I get a negative number. So some, you know, combination of 1 and 24. I don't see how I can combine those and get a 5. You know, I could multiply 2 and 12, you know, again, some combination of positive and negative to get -24. Again, I don't really see how those are going to add up. You know, if I make one positive and the other negative, I don't see how they'll add up to 5. let's see, what else multiplies to 24? Well, 3 and 8 work. So I'm thinking, oh, okay, I think I could make one of those positive and one of those negative to where they add up to positive 5. So we want a positive number, which means the larger number should be the positive number. So it looks like if we use negative 3 and positive 8, again, they multiply to negative 24, but if we add those numbers together, we get positive 5. Okay, so this is starting to make me feel a little bit better here. So what we do at this case, at this point rather, so let me go ahead and, again, copy this back down. 6x squared plus 5x minus 4 equals 0. What we're going to do is we're going to break up the 5x as we're going to use these values. That's the whole point of finding those. We're going to break it up as negative 3x plus 8x. Okay, so we're going to rewrite our 5x as negative 3x plus 8x. So, okay, there's my 6x squared. And now I've got negative 3x plus 8x. And again, if we combine those, we do get positive 5x. That's what we want. Minus 4 equals 0. Now what we're going to do is we're going to look at the first two terms and our second two terms, and we're going to factor out the greatest common factor. So if I look at 6 and 3, if I look at the coefficients, I can definitely factor out a 3. There's an x squared and an x, so I could also factor out an x. Well, in parentheses, I would need a 2x because 3x times 2x will give me my 6x squared. And then I would need, it looks like just a negative 1 because 3x times negative 1 is going to give me my negative 3x. I'm going to do the same thing for the second set of parentheses. So it looks like we've got an 8 and a negative 4. Well, I could factor out a 2. And it looks like we would need, what will we need? Just a, oh, not a 2. Let's factor out a 4, right? So if we factor out a 4, I would need a 2x because 4 times 2x is going to give me my 8x. And then 4 times negative 1 is going to give me my negative 4. So the thing that's important here is we need the same thing in the parentheses. Notice I have a 2x minus 1 in both sets of parentheses. That's good because now we can factor this. This is really going to be the greatest. I mean, we could factor further because 2x minus 1 is in common for both of these terms. So I could pull the 2x minus 1 out, and well, I would need a 3x left over, and I would need a positive 4 left over. So now you can think if you multiply 2x minus 1 times 3x, well, I'm getting this first term. And if I take 2x minus 1 and multiply it by positive 4, well, I would be getting the second term. So this factorization is now done. So we'll do the same thing. We'll take each thing in parentheses, set it equal to 0, and then we'll solve. Okay, so the first set, or the first equation, I could subtract 1 from both sides. Excuse me, add 1 to both sides. So we would have 2x equals 1. And then we could divide both sides by 2. So if we divide by 2, divide by 2. On the left, I'm just left with x. And on the right, I'm left with, well, 1/2. So that's one of my solutions. For the second equation, I could subtract 4 from both sides. So that would leave me with 3x equals negative 4. And then I could simply divide both sides by 3 and be left with x equals negative 4/3. That's going to be my other solution. So this is factoring by grouping. You know, you could have done this by trial and error. I think I actually even maybe got lucky and had it up here. It looks like I did have it just by chance. So, you know, if you're taking a quiz or an exam or whatever, sometimes it's a judgment call. You know, factoring by grouping obviously takes a few steps, right? We had to do quite a few things here, but you have to decide, is it faster for you to do factoring by grouping, or is it faster for you to do trial and error? And again, to me, it really depends on how many factors the coefficient on x squared has. and how many factors my constant term has. Because I'm going to get, if you have lots of factors, you're going to get lots of possibilities. So if your arithmetic is good and fast, you can always do just trial and error if you think that's the quickest way. But again, factoring by grouping is sort of a more, it feels like it's a little bit more of a procedure. Let's look at this same example, 6x squared plus 5x minus 4. So again, let's set it equal to 0. So again, we're trying to find solutions here. So not necessarily, factoring it is one way that finds the solutions. So another way that we can find a solution is by using the quadratic formula. So the quadratic formula says if you have a quadratic of the form ax squared plus bx plus c equals 0, our solutions are going to look like x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So, okay, well, a is the number in front of x squared. So our a value here is going to be 6. Our b value is whatever in front of x. So in this case, our b value is going to equal positive 5. And our c value is the constant. So make sure you include the sign. So here our c value is going to be negative 4. So if I fill in this formula, it says I would have negative b, which is 5. So I would have negative 5 plus or minus the square root of, well, b squared. So that's 5 squared minus 4 times a, which we said was equal to 6, times c, which is equal to negative 4, all over 2 times a. So 2 times 6. So now we can simplify this down. We'll see what we get. So this is negative 5 plus or minus the square root of, well, let's see, 5 squared is going to be 25. Let's see, negative 4 times negative 4 is going to be positive 16. Let's see, 16 times 6, that's going to be positive 96. Again, all over the denominator, 2 times 6, which is 12. All right, so this is negative 5 plus or minus the square root. So 25 plus 96 is 121, all over 12. Well, it turns out that the square root of 121 is simply equal to 11. So the arithmetic here is working out a little bit nicely. I mean, there's no guarantee that, when you simplify the square root, you're going to get a nice whole number. If this was a negative number underneath the square root, recall that that actually gives you complex or imaginary solutions, in which case we would say there's no real solutions to this quadratic equation. But in this case, well, we've got a positive number. It simplifies nicely to, again, the square root of 121 is just simply equal to 11. And now this tells us we have two different solutions. We have negative 5 plus 11, so we're going to keep the plus 11 divided by 12. And then we have negative 5 minus 11 divided by 12. And then we can simply reduce both of those. So in the numerator, negative 5 plus 11, that's going to be 6 divided by 12. Well, 6 divided by 12 is just simply equal to 1/2. And my other part, negative 5 minus 11, that's negative 16 divided by 12. Well, let's see, 4 goes into both the numerator and denominator. I'm going to get a negative. So 16 divided by 4 is 4. 12 divided by 4 is 3. So those are my two solutions. And notice that obviously agrees with exactly what we got a second ago, right? We had negative 4/3 and 1/2. So just another way to arrive at those solutions, negative 4/3 and 1/2. So, there's obviously a few more things that you have to worry about. You need to make sure that you can simplify numbers underneath the square roots. If you do have to worry about complex numbers, again, that's sort of another, just another thing to think about if the question does ask for complex solutions as well. But in a nutshell, this is everything you ever really need to know to solve quadratic equations. If you know these few techniques, you'll be in business, and as long as you're taking any sort of math algebra class, trig class, pre-calculus, calculus, linear algebra, differential equations, you'll see quadratic equations over and over and over. And so again, just make one side equal to 0, try to factor either by trial and error, try to factor using grouping. And again, for me, if I saw this type of question, I would probably honestly just jump to the quadratic formula. That's my own preference. If you like grouping, by all means, go for it. But yeah, if you have any thoughts or comments or questions, please feel free to post them in the comments. And yeah, let me know what you think. And once again, as always, I hope this helps you, and best of luck in your studies.